All right, hello everybody, and welcome back to the Math Puzzle Crash Course. Got a little different topic here. I want to talk about different notation in mathematics for performing calculations. The three main types are that you have infix, postfix, and prefix notation. Infix, postfix, and prefix are three different ways of writing expressions. They're equivalent in their outcomes, however. These notations are often used in programming languages, also in calculators to handle mathematical operations. Infix, postfix, and prefix are three different ways of writing the expressions. Again, they're equivalent in their outcomes. And so infix is where the operators are written in between their operands, and that's probably the most familiar one. We'll show some examples here. Postfix is where the operators are written after their operands, and then prefix is where the operators are written before their operands. So some of you may be asking, well, what on earth are you talking about? Well, let's start with infix, which is the most common. Everyone has seen this. Um, the operators are written in between their operands. For example, x plus y. And here's an example. You have a times the quantity x plus y divided by z. And per the order of operations convention, your addition is going to be performed first, which is the x plus y inside of the parentheses. And then it's followed by the multiplication and division going left to right. Now, as far as processing power, your infix notation requires more information to be available to your calculator or in your computer system, such as the order of operations knowledge, knowing that parentheses are going to, override the order of operations priorities. That information needs to be known in the computer or the calculator so it knows how to solve using this infix notation. Now, postfix is where the operators are written after the operands. You have something like xy plus. It's still the same thing as x plus y in infix, except in this case the operators are written afterwards. Now, an example, this is an equivalent example to what we saw before, but instead it's written axy plus times z divided by. And for some people, that may look a little bit strange, but if you're familiar with postfix, it'll make sense. Now, you keep in mind that here in postfix, your evaluation order here is always left to right, and parentheses or brackets can't be added to modify the order. Now, since it's been written with the plus, you notice that the plus operator appears before the multiplication. That means that the addition is performed first. So since the operator was written, but the plus was written before the times or the multiplication, then that means the addition is done first. So basically, this is causing the order of operations convention to be followed, but this is how it's done using postfix. So the addition's performed first here. That's consistent with the infix notation example, and it's consistent with the order of operations. And some people may recall PEMDAS or BODMAS as some common acronyms. Now, in the example, the xy plus is resolved first, which is the same as the x plus y in brackets or parentheses in infix notation. So the addition's done first, and then the a is multiplied with the result of x plus y. And then finally, that result is divided by z, because you notice that the division sign, that forward slash, is all the way at the end. So that's telling us at the very end, we're dividing by z. So again, that's equivalent to what we had before. If I back up again, this a, if you see this a times the quantity x plus y divided by z, that is equivalent to this in postfix notation. So it might seem a little confusing at first, but more people are familiar some people, especially engineers, are familiar with it. Postfix is actually considered a more natural method, and that's for computers, not necessarily for humans, but it's a more natural method for the way computers work, since computers are really good at processing information in a stack. You know, they push data into a stack, evaluate it, and then remove it as needed. And here's a good postfix example where you have 5, 6, 7 plus 4 minus. Now that's again, that's postfix, but that's the same as writing it out as 5 plus 6 plus 7 minus 4 in standard infix notation. Now again, this is a fairly simple example, but it's just to prove a point about why postfix is a little bit more natural. We don't have any multiplication or division to complicate it here, but we're going to work through this one. So with postfix notation, if we want to look at a stack, basically the first number, we would push the 5 onto the stack. You can think of this as a storage location, whereas each number gets pushed in, we go down the stack. So we push 5 onto the top of the stack, and then as going left to right, we run into a 6. Well, the 6 gets pushed onto the stack at the top, and the 5 just moves one position down in the stack. But then going left to right, we run into a 7. So the 7 gets pushed onto the top of the stack. Everything else gets pushed down one position. Then we run into an operator going left to right, which is our plus sign. Now the plus sign is telling us that we must pop the top two items from the stack and then apply the addition operator. So what that means is we're actually going to pop off the 7 and the 6 and add them together. So we do that, and then I'm sorry, that's actually a mistake here. It's not 7 plus 6. Let's rewrite that here. Let's rewrite this with a pen. That's not 16. That should have been 7 plus 6. 7 plus 6 equals 13. And then the result is pushed onto the top of the stack. So notice we popped off the 7 and the 6 and replaced it with the result of the addition, which is 13. Now the 5 is going to still sit down below there, underneath. All right. So next, after that, we go left to right. Um, we're still working with the addition operator at this point. We're still adding. We're adding 5 plus 6 plus 7. So we've already added the 6 plus 7, but we haven't added the 5 yet. So now we need to pop the 13 and the 5 from the stack and then put the result of that addition back onto the top of the stack. So here we're taking 13, adding it to 5 and getting 18, and now the top of our stack has an 18 on it. And if you notice, that's the same thing as adding 6 plus 7 plus 5, or same thing as adding 5 plus 6 plus 7, basically. Um, so now that that addition is resolved, we push the 4 onto the stack because going left to right, remember, postfix, we're evaluating left to right. We have a 4, so we push that on the top of the stack. The 18 would move down one position. Then going left to right, we run into a subtraction operator. And now we must pop the 4 and the 18 from the stack and then process 18 minus 4. Well, 18 minus 4 is 14, so we put that result back onto the top of the stack. So now we have a 14. That's the result of that is the answer to this problem. And again, I want to make a note here that postfix notation is also referred to as reverse Polish notation or RPN. You may have heard that in certain calculators. Postfix, Hewlett-Packard is well known for their reverse Polish notation or postfix calculators. These were really well known to engineers. I used a couple of those myself back in the day. Some models continued to use this notation, but it was really popular back in the 1970s and 1980s. Now, another notation method is known as prefix, where operators are written before the operands. And here, an example would be Again, we have our A times x quantity x plus y divided by z. Again, that's in the standard infix notation. But if we were to write that using prefix notation, it's actually going to be written as we have the division, the multiplication, the A, and then the addition operator, x, y, z. Now, keep in mind, although the operators are evaluated left to right, they perform the actions on the terms to the right. So it's a little, maybe a little bit more confusing if you're used to infix or postfix. It gets a little complicated when those terms to the right are the result of other calculations. Then the evaluation order of operations needs to change on the way that this works. So, for example, you've got this plus xy here that we need to look at. In this case, using prefix, the addition is actually resolved first, because keep in mind, um, this we have an operation all the way to the right here, and these operations depend on this. So um, it might be helpful to see this using some unnecessary brackets or parentheses to understand the order that the prefix is resolved. These aren't necessary and they're not really used in prefix notation, but I've written these in to kind of help explain it. So in other words, keep in mind this is the innermost set of parentheses, so the plus xy is resolved first, or addition is resolved first. And I'll keep in mind too that the prefix notation is also referred to as Polish notation, not RPM. That's wrong. Um, no, it's or I don't even know if it's known as PN, but it's Polish notation, not reverse Polish notation. So I'm hoping this is a helpful description. It might be a little bit confusing, but if you ever hear anybody refer to infix, postfix, or prefix, these are descriptions of how they work. Probably infix is something that everybody's seen. Postfix, probably something more relatable to engineers. Anybody that's worked with an old Hewlett-Packard calculator where reverse Polish notation or postfix was very common. So I hope this video again has been helpful. Please consider like, share, subscribe, and I look forward to seeing everybody in the next video.